Hello all, welcome to the channel. This is D Square and today I'm gonna show you how to make a drop test with the use of flexible target. In our previous two video I talked about how to make drop test with the use of gravitational height and velocity factor, but in this video we choose the target plane is rigid. So right now here we are considering the target plane is flexible. Okay, so I'm starting the tutorial. I'm deleting this study. Okay, so here you can see that this is my car outer body and the thickness is 2 mm. Okay, so I'm starting the new study and get down here and that is drop test. Click here and right here for and first applying the material. Right now I'm applying material. In this we are applying here aluminum alloys. In alloys we are applying 6061 alloy. Apply and close. Here you can see that material is applied successfully. Now here we are making setup. Right click here, define. Okay, here we are doing also velocity impact. First, we need to give the direction. So here I am giving the direction, that is reverse. Okay, and here we need to write a speed. That is I am writing 130 meter per second. Okay, now need to apply gravity. Gravity is downside. Okay, fine. Here that is written is a target. Now click here parallel to reference plane. It shows where is your target body. So I am choosing this plane. So this is my target body or surface. Okay, now here we are doing flexible target. So I am writing here, I am making a redwood. So first need to write here the normal stiffness of redwood, that is 14.1, that is 40.1, and this one is tangential stiffness, that is 9.5. Okay, this is mass and that is 410, and here I need to write that is thickness of striking surface, that is I am taking as 40 mm. Okay, fine, all things are filled. This is for damping, we don't need any damp, and this is for friction coefficient. Right now I am taking as a coefficient is 0. Okay, click right. Now right click result option, define. Here you can see that the solution time after impact is 390.2 microsecond. So I am changing it to 50 because it takes less time to simulate it. Now click right. Now apply mesh, right click create mesh and drag the arrow to find. Okay, somehow. Okay, now right mesh is happening. Okay, now our mesh is completed. Okay, now run the study. This study take more time, like 5 to 7 minutes. Here you will see the remaining time. Okay, so my remaining time is 6 minutes and 53 second. 6 minutes and 20 second. I am close now. 11 second is remaining. 4 second. Okay, study is completed. First, let's see displacement. Okay, now right click on displacement setting. Here get floating. Okay, and this is my timing, that what happened after 50 microsecond of impacting. Okay, now scale is true 1:1, and in this option, okay, now first right. Now let's animate it. Frame is creating. Okay, done. So here you can see that the structure is failing. Right here you can see that clearly it going to upside, and this is for only 50 microsecond. Okay, here the maximum displacement is for 50 microsecond, it is 8.384 mm. This is my maximum displacement, and it shows here. Here is the main failing part. Okay, now click right. Let's choose here to line. Okay, now once more animate. Okay, so here we can see that the what happening with the body. Here is structure falling. Okay, now click right click here, and get here continuous, and go here ISO clipping. Here we can see the value, the where is the maximum displacement. Here this part has the maximum displacement. Here we can see the arrow, and when you drag the arrow, it shows all minimum displacement also. Minimum, and these are the maximum displacement. Now cancel it. Now go for stress. Right click, setting. Okay, chart option, and make here floating. So here minimum and maximum annotation. Now definition, and get here megapascal. Okay, this is also 1 scale. Now click right and animate. Frame is creating. So here you can see that the stress value is increasing in this part. Like also you can see the graph here. So this is my maximum stress value and this is minimum is also 0. And after this test, the material is also fail and deform. And in the this part trace is 0. Okay, now fine. Now click right here and right click and ISO clipping. Okay, here you can see they drag the arrow. The maximum stress it shows here and here and also here. If you drag more, so it shows this part has more maximum stress because the design of this part. Here you can see that the design is open in bottom side, so this part has more maximum stress. If you want to see strain, you can also see right click animate. So here you can see where is the atom changing in size. So this front atom is changing their shape. Okay, now cancel it. Click here once more displacement. Okay, now right click here setting and get here definition. Go down and click here automatic. So it shows a scale of true scale. So right now here you can see that the more deformation, but value is our same as its original 8.384. Okay, now click animate. Okay, so here you can see the displacement. If I put here more microsecond, like here I took the 50. If I make 100 and more than, so it will also look like this in true scale also. Okay, so here you can see the what's happening with the car. And in the normal view you can see that this is our wooden wall, and the car is going inside the wall and wall is breaking also. Here you can see the effect area. Okay, right here now we need to see stress, so click right click here and animate. Here you can see that the stress value is also same as previous. Okay, so like, share and subscribe our channel. Thank you for watching. Thank you all.